With that, I think I'm going to turn this over to Laura Katzman of the Flathead Land Trust, and she's going to do our presentation. Thank you.
All right, thanks so much. Well, I'm excited to be here. I've been giving presentations for a bird education program that was developed by myself and Danny Olson and Fish, Life and Parks about 6 years ago, targeted at the 7th grade age group because they were the age class or group that it seemed like the program fit best into their science curriculum, and it was an age group that didn't have a lot of field trips going on. From my own experience with my kids, I knew this. And so we put together this bird education program. It's kind of modeled after the Hook Down Fishing program in how it's implemented. So instead of going in one day and doing a bunch of information dissemination and field trips, spread it across the whole year, do a classroom presentation here and a field trip there, and it all adds up to about a day by the end of the school year. But it's really fun, and I was continuing to give the presentations. I thought, this is fun for all ages. It's not just for 7th grade, and after all, we're all just big kids anyway. So I thought this would be fun to give to Flathead Audubon. So it's very entertaining, I think, anyways. And what I've done is I've taken the best of all the things that I give to as presentations to the 7th graders throughout the year and put it into one presentation for you guys. And basically a little bit more detail of what we normally would do. So I go to a 7th grade classroom and give a presentation on how amazing birds are, meaning how great of adaptations they have, both physically, physiologically, and behaviorally. And the adaptations part of it is what fits into the science curriculum because they're learning about that in 7th grade. Then I end the presentation with a little bit more detail about sandhill cranes, and in the fall we go out to the West Valley and view the sandhill crane staging area and view birds from the bus and from the viewing area. And they're easy to see, and the kids have a good time. Then in the winter, I go and give a presentation specifically about birds of prey and their adaptations. We dissect owl pellets, and then we have Carrie Gabriel, the Montana bird lady, coming with her hawk and falcon live birds to show the kids. And then in the spring, I come in again, give a presentation about waterfowl, and we play a game, a Jeopardy game, just like Jeopardy on TV. But the kids are doing the categories based on what they've learned throughout the year about birds and their adaptations. And then we go on a field trip to view the spring migration, usually church to church slough. And this year, I'm going to be, so the other thing I guess is I go in to a school for 2 years about, and after the 2nd year, I'm helping the teacher carries on doing the bird education on their own. Some help, but not much help. And that way I can have just one person, myself, be covering a lot more ground. And so this year I'm working with the Big Fork Middle School for the 2nd year, and I'm starting new schools. And the new schools, I decided, since we're doing more work in the Mission Valley, are going to be in the Mission Valley. So starting, actually I decided to start them this year anyways, because I have time. So I'm going to be doing, working with middle schoolers from the Two Eagle River School and the Ronan Middle School the rest of this year. So it's a lot of fun. We've worked with Evergreen Junior High and the West Valley 7th graders and the Big Fork 7th graders. I think Denny also has done this similar program with other 7th graders in the Valley as well. So this is going to be just like I give to the 7th graders, so it's going to require some props and some volunteers. All right, so birds are amazing. There are over 10,000 species of birds in the world, and they dazzle us with their colors and their feathers, just like this lilac-breasted roller from Africa that's got 8 different colors in its feathers, and the resplendent quetzal from Central America that has tail feathers that grow 3 feet long, and they take 3 years to grow that long. There's also just amazing colorations of birds from Southeast Asia. We've got the mandarin duck and the golden pheasants from China.
When you're sitting in the back, it's cool. She's just like,
And they come in all shapes and sizes. So the heaviest flying bird is the Cory bustard. It stands about 4 feet tall, and it weighs 42 pounds. So that's a lot. And just to demonstrate how much that is, I've got this jug of water. We can pass it around. And you have to keep in mind that this Cory bustard weighs twice as much as this jug of water. And it's good to feel it. Just think about it. If you fly, this is how much you weigh. It's pretty amazing. And then the smallest bird in the world is the bee hummingbird that lives in Cuba. And it weighs less than a dime. So I'm also going to pass it around a dime so you can feel the contrast. All right. And then in North America and in Flathead, we also have the biggest bird of North America and the smallest bird of North America. So the biggest bird in North America by weight is the trumpeter swan, and the smallest is the calliope hummingbird. And the calliope hummingbird weighs about as much as a dime, and the trumpeter swan weighs about 1.5 times that jug of water. So birds have so many variations. They also come in flightless form. So the largest bird in the world is a flightless bird, the ostrich. Does anyone have any guesses as to how tall the ostrich is? You guys have to guess. 5.5 feet, taller than that.
8 or 9.
9 feet tall. And how much do you think it weighs?
A lot.
You guys have to guess. Come on, all the kids guess. Great, more than 200 pounds.
What?
320 pounds it can weigh up to. So that's pretty amazing. And another really... What?
Is that what just in a beast?
They're just big birds. So another really interesting flightless bird is the emperor penguin. And they face a lot of extremes. So they're the only animal to inhabit the open ice of Antarctica in winter. They face wind chills as low as minus 76 degrees Fahrenheit and blizzards with 124 mile-per-hour winds. And they can dive deeper than any other bird, down to 1,850 feet and stay under for 20 minutes. And despite being flightless, they migrate, by walking of course, across up to 50 miles of ice every year to their breeding grounds. And then there's a matter of speed. The fastest animal on the planet is the peregrine falcon. And it dives at speeds up to, anybody guess? 200 miles an hour or over 200 miles an hour, they've proven anyway. 250, okay. Well, that's gone up since I investigated this last. All right. Now I need a volunteer to come up to the front and help me out. You get to be active. Okay, great. All right. So, hummingbirds flap their wings a lot of times, really quickly. So we want to see how many times a person can flap their arms in 10 seconds. So what I'm going to count the seconds. You guys are going to count the flaps, and you can do them as fat, like big or small as you want. And you guys are going to count how many times you can flap your arms in 10 seconds. Ready? Get set? Go.
whoa!
That's not her alarm.
Stop. How many times? 50. That's very good. You're better than the 7th graders. Excellent job. So you can sit down. So, yes, very good. So 50 times. So a hummingbird can flap its wings 700 times in 10 seconds. That's 70 times a second. or at least this ruby-throated hummingbird can. They vary, of course, by species. Okay, so how long do you think you could continue flapping before you'd be tired? Just curious.
10 seconds.
5 minutes, okay, that sounds reasonable. So, get this, bar-tailed godwits have an astounding migration flying nonstop for 8 days. They go across the Pacific Ocean from Alaska to New Zealand, a distance of more than 7,000 miles. Okay, so enough flapping. Let's talk about something that humans do better than fly, right? Running. So, now you don't have to answer this, but think about this. So, how far do you think you could run in a year? So let's say you ran 10 miles a day. That would be 3,650 miles, right? Well, the Arctic tern has the longest migration ever recorded. It has flown the equivalent of flying around the Earth twice, plus 10,000 miles, or almost 60,000 miles. All right. Then we'll talk about some other amazing things about birds' flight. Let's compare how fast a person could run the mile compared to a bird's flying. So think about, what is an average person speed to run? How many minutes does it take to run a mile? 6 minutes, 5 minutes if you're really fast, maybe 4 minutes if you're an Olympian, right? So the black-pull warbler's flight is the metabolic equivalent of running a 4-minute mile for 80 hours straight. Because it flies, not unlike some of the terns that kind of might glide a little bit, it flaps a lot. It flies 2,000 to 2,500 miles over water from New England to South America, staying aloft 80 to 90 hours continuously, an effort that researchers concludes requires a degree of exertion not matched by any other vertebrate. So all this migrating takes a lot of energy. And if a black-pull warbler burned gasoline instead of body fat, it would boast getting 720,000 miles to the gallon. Some birds increase their body fat the week before, the day before they migrate. Some by 5% the day before they migrate. So if a person, say you weigh 150 pounds, wanted to gain as much weight as many birds do before they migrate, how many burgers do you think you'd have to eat the day before you migrated? Now I need some guesses for sure. 105. Could you imagine if I ate 105 burgers, if I could even do that in a day? I would not feel like doing anything but taking a nap. Not flying long distance, right? So how can birds do this? It's ridiculous, right? So birds are designed for flight. They have hollow bones to reduce their weight, and they don't have teeth because teeth are heavy. Instead, they have a special organ called a gizzard that helps grind up their food by just ingesting a small rock. They have air sacs in their bones to increase the efficiency of getting oxygen to their muscles because it takes a lot of energy really quickly. They have to be able to get all kinds of energy to the muscles. They also have a large heart for their size. So if we were birds, our heart would be 6 times bigger than it currently is. And they have a very rapid heartbeat. So if you think about a person's heart rate as 60 to 100 beats per minute, what do you think the range of a bird's heart rate is? With hummingbirds having the highest heart rate, number of beats per minute. Guesses? 800's in the range, so 500 to 1,000 beats per minute, with a hummingbird having 1,000 beats per minute.
The slowest is 5,000?
Yeah.
Like an ostrich?
Actually, birds like penguins can really reduce their heart rate too, so that there isn't quite a range, I guess. But yes, most birds it's 500 to 1,000 beats per minute. So how organisms do this kind of stuff, like birds in general are adapted to fly, right, compared to other animals. There's other things that they're adapted to do, the differences between species of birds, for instance. An adaptation, what is that? So this is what I'm, how I get into the 7th grade classroom, you have to have some definitions of some scientific words, right? So it's a change which makes an organism better suited to its environment. And of course, the birds in general, their greatest adaptation is migration. So the ability to seek out different habitats. And what is a habitat? Well, home is where your habitat is, right? So it's everything you need, from food to shelter to other things for survival. And there's a variety of habitats out there: wetlands, forest, prairies. And if you're going to take advantage of the different habitats, you're probably going to look a little different. You're going to have a little bit different adaptations. What was that? Oh, right. So how do all these organisms become different? So different, like some birds have really long bills and others have really long legs. How do they get to be this way? Through the process of natural selection. So that's the process by which organisms become better adapted to their environment. And I always tell kids, do you look exactly like your brother or sister? You come from the same parents, but you don't look the same. And if you come from tall parents, you're usually taller. If you come from short parents, you're probably shorter. Birds are the same way. In their nest, they're not going to turn out exactly like their siblings. Maybe one of them one year has a longer bill than the others. Maybe that year was a drought year, and having a longer bill helps them to get the invertebrates in the mud, which makes them survive and become stronger and survive better than their siblings. They survive to have offspring, their offspring with just a little longer bills, and over long periods of time, maybe the drought lasts hundreds or thousands of years, it's climate change, this is what happens. And these birds are specialized, right? There's advantages and disadvantages to being specialized. It can really help you have a unique place in the world, a unique ecological niche to help you survive in a competitive world. But if climate conditions change, it can be a disadvantage and be a bad thing to be so specialized. All right. So one of the biggest differences between birds are their bills, helping them to take advantage of different food sources, right, to reduce competition for themselves or between the different birds. We're going to watch a little video, and I think this is a very well done video for kids, but I always tell kids this, like when we're going on to a field trip, you're not expected to remember what all the birds are called or learn what they're all called, but if you just know a few things about their structure and their behaviors, you'll have a lot of fun watching them because you'll know a lot about them just by knowing just a few things that are generally about birds in general, like about their bills. As soon as you see them, you're going to know where to look for them by their bill. So let's watch the video if you guys want to cue that up.
Hi, I'm Sarah. I'm a student at Cornell University who's interested in field biology, especially birds. And today, we're going to be talking about the incredible world of feeding adaptations in birds. So when it comes to food, some birds, kind of like humans, are generalists. Birds like jays or gulls will eat pretty much whatever they can find. However, most birds specialize in certain types of food, which means that how they look and how they behave is determined in large part by what they eat. So this means that even though different species of birds can look very different, if they eat the same thing, they'll share a lot of very similar characteristics. The first group of birds we're going to be talking about are the ones that you're probably most familiar with. These are the seed specialists, which are basically your typical backyard feeder birds. Seed eaters have sturdy, triangular-shaped bills. This shape allows birds that eat seeds to have an incredible amount of power, which they need to crack through the protective outer covering of seeds. Fruits and berries are sweet snacks enjoyed by a variety of bird species. However, the real specialists are the nectar eaters. That's right, I'm talking about hummingbirds. Unlike seed eaters, hummingbirds have these long, fine bills. They're not very strong, but they're perfect for allowing these birds to reach deep inside of flowers where the nectar is hidden. Hummingbird beaks can be short or long, straight or very curved. Each beak is kind of like a puzzle piece, specifically shaped to fit into a specific type of flower. Our next group of birds has a set of even more incredible adaptations that helps them live life in or on the water, where fish is what's on the dinner menu. There are many different ways to catch a fish, but most birds rely on a beak shape that's long, sturdy, and pointed, sort of like a spear, which allows them to catch and hold on to slippery fish underwater. When it comes to actually eating the fish, once you have it in your bill, the bird has to kind of toss it up, rearrange it to where it's going the right way to get down their throat, and then try and chug it down without it slipping out and getting back into the water. Other birds that eat fish actually dive below the water to find their food. Herons and egrets will remain perfectly still until just the right moment to strike. Others take a more active approach. You may have seen some birds walking around shaking their legs like this under the water. What they're doing is trying to scare up any small fish or bugs or shrimp that are hiding down in the mud under the water. Black herons jump around like ballet dancers. They hold their wings out in front of them, creating a little patch of shade, and then when a fish swims in, thinking it's a safe place to hide, the heron strikes and gets its meal. Many species of ducks and geese have broad, flat bills that are perfect for straining aquatic plants out of the water. Our next group of birds are powerful hunters on land and in the air, where they feed on small mammals and even other birds. Raptors are meat eaters and typically include hawks, eagles, falcons, owls, and vultures. Raptors are distinguished by the fact that they kill their prey with their feet. Raptor feet are incredibly strong and equipped with sharp talons, which are hooked claws that they use to grab and hold on to their prey. Raptor beaks are very hooked and sharp for tearing through meat. They're also strong enough to crack through bone. Okay, so now we've talked about seeds and flowers, fish, and other animals. But I've saved the biggest and most important food group for last. Any guesses? The answer is insects. Insects are an important food source for a large number of birds. They're high in protein, and you can find them pretty much anywhere. So even birds, like the seed eaters we talked about, that specialize on other types of food, will still eat insects if they have the chance. There are also a few groups of birds that are specially adapted to live off insects. Warblers have small, short bills that they use to pick insects off of branches or leaves, which is called gleaning. A lot of times you can see these birds hopping around in the bushes or the tops of trees looking for insects hiding beneath branches. Many shorebirds, like sandpipers, have long, thin, probing bills that they use to dig into the mud where bugs might be hiding. Another group of birds catches insects in midair. Swifts, swallows, and flycatchers have relatively short, stubby, unimpressive bills, but their mouths are really large. Sort of like a bug net, it gives them extra surface area to gulp down insects in the air. Some birds dig for insects in the sides of trees. These birds typically have beaks that are short, blunt, and chisel-like, very sturdy so that they can dig into the sides of trees or lift up pieces of bark looking for insects. Now that you've learned about some of the key feeding adaptations in birds, head outside and find some birds. Take a look at their beak, their feet, their feathers, and how they act, and see if you can figure out what it is they eat.
All right. So, other adaptations for birds include having different feet. So in the video, and as you guys know, the extremes between the birds go from the talons that are on birds of prey to webbed feet on waterfowl to birds that look like waterfowl but aren't, on coots that have lobed feet. And the lobes, of course, can be folded in so that they can walk on land and not be so clumsy looking as a duck waddling around. But they can spread them out so they can use them to swim in the water or walk on soft mud. And there's all kinds of variations of feet. There's also variations for how birds can use their feet. Osprey and owls can rotate one of their toes forward to help them hold on to critters. And osprey and some of the other fish-eating birds have spicules on the bottom of their feet, or little rough bumps to help them hold on to slippery fish. Birds also have different leg lengths and different leg positions on the body. So some birds that have long legs use them, of course, to wade around in the water to fish. But some birds have legs on the back of their bodies, like diving ducks. So these birds aren't able to come out on land because they couldn't walk very well, but they can easily propel themselves underwater and swim underwater, where dabbling ducks don't need to do that because they're just tipping their butts up or rear ends up to feed, their tails up. But on land they can walk around very easily, and they can get away from predators very easily as a result of that too. Some birds use their long legs just as a way to stay safe from predators at night, like these sandhill cranes. Birds have different wing shapes and lengths, right? So the diving ducks have little short wings to make it easier for them to swim underwater, but they have a hard time taking off with these tiny little wings, so they have to run across the top of the water to get up enough speed, like a plane on a runway, taxiing, to take off, where dabbling ducks have large, broad wings to enable them to take off on a dime or take off from land. And there's another little educational video that I think is really fun on dabblers versus diving ducks, and that this helps a lot when we're looking at waterfowl, because waterfowl, again, are kind of tough for kids to identify at a distance with binoculars. Go ahead. All right, so that just helps everyone, I think. And someone says, hey, there's a diving duck out there, you can think about all those things, right, as you're looking for the diving duck. And I always tell the kids, did it disappear? And then when you told your friend there was a duck out there and then it disappeared, well, you know, it was a diving duck, right? So things like that are kind of fun. Okay, so some more things that are just absolutely amazing about birds. Their eyesight is one of them. So think about this. There's different kinds of eyesight depending on whether you're going to be hunting during the day or at night. So if you think about this competitive world, and all of a sudden some species says, no other birds hunt at night. That leaves all the food at night for me. I mean, think about how these things evolved, right? And then over a long period of time, all these adaptations developed too, and was the eyes. So if you're gonna be out at night, you want big eyes to let lots of light in. You want to be able to see black and white well, so there's lots of rods in their eyes. You want hunt during the day. You have lots of cones in your eyes, like people. You can see color. And we'll watch a video that shows how amazing hawk eyesight is. Usually we'll be able to skip them
Hawks
shortly.
see
Here
the
we go.
world in way more detail than us. They have 8 times better resolution than humans, and hawk eyes can see wavelengths of light that are invisible to us. Here, I'll break down what hawks see, the weird differences in their eyes that give them supervision, and the argument over whether hawks or eagles have the best vision in the animal kingdom. Hawks can spot a rabbit from over a mile away. Their amazing distance vision makes them pretty scary predators. Average vision for humans is 20/20, while average vision for hawks is 22 or even 21. That means that from 20 feet away, they can see the same level of detail that we'd only see from 1 to 2 feet away. They have a 280-degree field of view, which blows our field of view of 135 degrees out of the water. This means that as a hawk is flying, they can simultaneously see everything below them, plus lots of the sky around and even behind them. The significant overlap between the field of view of each of their eyes gives them really good depth perception, letting them very accurately judge distances when they're hunting. Hawks have huge eyes compared to the size of their head. Our eyes weigh less than 1% of the total weight of our heads, while hawks' eyes make up 15 to 20% of the weight of its head. They also see wavelengths of light that are invisible to us. Cones are the color detecting cells on our retinas, and hawks have very high densities of cones in their eyes. They also cover ultraviolet wavelengths in addition to the colors we can see. Seeing ultraviolet light is great for hunting because it lets them perceive details on potential prey that are invisible to humans. A semi-transparent third eyelid helps protect hawks' eyes while keeping them moist as they're flying as fast as 120 miles per hour. Time for the ultimate showdown to see who has the best vision in the animal kingdom. Hawks versus eagles. Crowning the winner depends on your definition of best, though. Eagles do have slightly better distance vision than hawks, spotting a rabbit from up to 2 miles away. However, hawks have better color vision than eagles, which does help for differentiating certain animals from their surroundings. So they have different advantages, but in terms of purely seeing the most detail from far away, eagles win this one. As if hawks weren't already terrifying, they have excellent hearing and can pick up on faint noises being made by prey that are outside of humans' auditory range. All of that makes me pretty thankful I'm not a rabbit or a mouse that always has to be worried about being snatched up into the sky.
All right, pretty fun, huh? And hawks can see, because they can see ultraviolet light, they can see urine basically of voles. So when they're flying, they see all the trails from voles. They know that's a good spot to stop and hunt, right?
Yeah.
Okay. So birds, as this video alluded to, have also have very good hearing, especially owls. So if you think about being adapted to be out at night, you want to be able to hear things you can't see as well. You also have to be very silent so that you're able to sneak up on your predators. And then another thing is owls' ears they're on the sides of their head. The ear tufts are not their ears, which you guys probably know. The kids don't always know that though. But the owl's ears are offset, so one is higher than the other, so they can hear things at different angles coming in. It helps them hear them at slightly different volumes and slightly different angles, basically, to help them pinpoint their prey. And we're going to watch a video on great owl hunting because it's quite amazing. And they hunt during the day in this video, but you can imagine an owl hunting at night using the same skill.
Many animals will run from their predators. But just because an animal can run doesn't mean it can hide from a predator with super hearing. The great gray owl lives in the Arctic, where even in summer, its meal can be buried under inches of snow. To hunt, it locates its favorite prey, mice and other small rodents, by listening for movement far below. The feathers surrounding each eye function like a dish antenna, directing sound to the ears. Each ear receives sound at a slightly different volume and angle, which allows the owl to pinpoint where the sound comes from. It focuses on unsuspecting prey as much as 2 feet beneath the snow and sets off on the attack. They continue to listen throughout the approach. To finish the job, owls have become masters of the dive bomb. Super hearing will ensure this owl a full stomach tonight.
So I always think that's an amazing video. The little mice are moving around the whole time, they're flying, they still somehow can get the owl, or get the prey. So if you're going to be flying and listening, and at that level of listening, you're going to have to fly quietly so you don't make so much noise yourself that you can't hear your prey. So owls have special fringes on their feathers that gives them almost silent flight. And we've got another video, because these are such cool videos, that shows how owls fly so silently.
Challenge: to fly over a series of super sensitive microphones.
Good girl.
Oh, she's... No.
And now, it's Kenza's turn.
No, nothing at all. Absolutely quiet. It's amazing.
But what have the microphones picked up? The decibel waveforms show the sound being generated by the birds in flight. Each spike is an individual wing beat. But with the barn owl, there's almost nothing.
Pretty cool, huh? I always think these things are amazing. So, just remember, I get to spread all these videos out over 3 different presentations, but for you guys, I had to show you all the cool things, right? So the behavioral adaptations are the last adaptations we're going to talk about. They're some of the coolest. So, other than migration, we have some cool behavioral adaptations of some birds worldwide, like the Indian gray hornbills. So these guys are monogamous and have strong pair bonds. And I don't know if I would trust my significant other on this, but they nest in cavities. The female enters the cavity and seals the cavity, and then she lives in that cavity where the male feeds her through a slit and takes away waste, and she molts all of her flight feathers and lays eggs and raises the young and stays in that sealed cavity the entire time, which basically takes around 60 days. So that's pretty amazing trust, and I think it's good adaptation because it's a cavity in a tree, but in India there's lots of predators, snakes and things that are going up and down trees looking for eggs and little ones, and so it's a way to keep your little ones safe. Then there are some of the more wild migrations, I guess you'd say, from cranes. Some cranes, there's lots of different species of cranes in the world, 15 I think total, and some of them go as high as the Himalayas. They could cross tundra, they cross deserts, forest, everything. So they are pretty much a species that is in awe by lots of people across the world. And because a lot of countries are kind of more similar to the size of our states, so they're small, these cranes, and a lot of birds, but the cranes are big and showy and something people are attracted to, are crossing boundaries of countries to go from one area that they need to another. So they become symbols of peace, and they've been really useful to help keep peace between countries. They're long-lived birds, and they mate for life, so they're also symbols of longevity and prosperity and that kind of thing. Oops. But back to the behavioral adaptations, they're really cool. So if you go into the tropics, there's all kinds of cool things. So near where birds of paradise are, and these are not considered birds of paradise, but they're close to where birds of paradise live, are bowerbirds, and they're amazing. You guys may have heard of the bowerbirds before, but in case you haven't, so there's 27 species of bowerbirds, and they all construct nest-like structures called bowers to attract their mates. These bowers are very colorful. They decorate them with all kinds of colorful objects, and they will not only have these bowers to attract their mates, but once a female comes into the male's bower, it will also do a dance for the female. And the female goes to several bowers before she decides who to mate with. So there's a lot of competition for these poor males. They're just doing their best. They're pretty cool. There's also a bird that is similar to a bird of paradise, but lives in Central and South America, called a red-capped manakin, and they perform such a cool courtship dance. It almost looks like a moonwalk. And the females select the mate based on the quality of this dance, and again, the females will snub males left and right because their dance isn't quite right. So you have to see this dance to believe it. So this is another short video that shows the mannequins dance. The world's weirdest.
A bird nerd rarely gets the girl. Just ask this avian Casanova. The mannequin. There are over 50 species of this showy little bird, and they all go full out to court the ladies. At breeding time, the brightly colored males stake out a staging area called a lek, the bird equivalent of a singles bar. A branch serves as the dance floor. The act isn't all snazzy steps. Sound is just as important. The buzzes, whirs, and snaps may catch a lady's eye, boys also warns other males. Back off, she's mine. And if all else fails, show some leg. The competition is so fierce that only alpha males will mate. Now that makes online dating look easy.
And now, of course, I've saved the best for last. So birds of paradise are known for their striking colors and mating rituals and dances. There's 42 species of birds of paradise found in the tropical rainforest of New Guinea and Australia. And they're very colorful birds with elaborate dances. And they're very difficult to see, so we're lucky that there's some people out there that have gone to great lengths to video them so that we can enjoy them. So we'll go to that video, and this will be the last big video of the day.
They go from expected to extraordinary in the blink of an eye.
You're awe-stricken. They transform themselves to something that you've never seen before.
They swagger and serenade. They dance and display. They're unlike any creatures on Earth, and one of the most astounding phenomena ever witnessed. The birds of paradise. Found here in the nearly impenetrable mountains and valleys of the island of New Guinea, in the greatest remaining tract of rainforest in the entire Asia-Pacific region, they exist nowhere else on Earth.
The vast majority of the land around here has no road access. You're just looking up into a wall of steep slope, and you can tell that this is just ridge after ridge and valley after valley.
Evolutionary biologist Ed Scholes and wildlife photographer Tim Lehman have spent the better part of a decade trekking into this isolated wilderness in pursuit of all 39 species of these miraculous birds.
Well, the only way to see a kingbird of paradise is to climb up into the trees where they live, so I'm heading up to my platform.
They've been photographing, analyzing, and recording their every move, every behavior, in an attempt to comprehend their secrets. And in doing so, revealing extreme examples of the miracle of evolution.
The birds of paradise represent one of these singular events of evolution that stand out, that are extraordinary. They're something that's without precedent, something that evolved that's so unique and so exceptional that you're driven to say, why? Or, how did that happen? How did that come to be?
The birds of paradise are remarkable not only for their exceptional beauty and almost otherworldly appearance, but as veritable living textbooks on adaptation and sexual selection
the females are looking at this whole package and can discern something about him by minor variation. The more complex it is, the harder it is to make it look right. You know, if one little feature is out of whack, you're going to be able to tell.
What about New Guinea has led to these birds evolving here and nowhere else? What function do their outrageous plumes and ornaments play? And what exactly are they doing?
For me, it still always goes back to the original driving question, you know, and that's, how did it happen? How did the bird of paradise come to be?
Witness diverse strategies of evolution at work, and experience one of nature's most extraordinary hidden wonders up close. A world where beauty and behavior are intertwined. A spectacle not possible any other place on Earth.
All right, well, that helps you get a feel for what you guys already love, birds, but how amazing and different they are in one package. I think it's so fun to share this with the kids, and the kids get it in little bits, and they do, their eyes light up, and by the end of the year, they call me the bird lady, and they see me somewhere, and they're like, aren't you the bird lady? Are you gonna come do a program for me in 8th grade? I'm like, they're like, kids at that age they look like little adults, but they're still kids at heart. So when they do that kind of thing, you know, it looks like this adult coming up to you saying that, and then there's this little kid, like, excitement about birds is really great. So another part of what I was asked to do when I came here is kind of give you a little update for most of what I do with Flathead Land Trust, our land conservation. So I do have just a little bit, just a couple more slides. So in the last year, we've had a great year. We've completed 7 conservation easements. So you guys all know about Owen Sourwine, the 402 acres of the confluence of the Stillwater and Flathead rivers. We also had, back in January, 500 acres conserved on Egan Slough. So these are a couple pictures of kind of where these things are. Those are 2 big projects. Sometimes my fingers don't get the clicking right. And then we've got Lucy here in the audience. So she conserved her family property, the 76.5 acres just southeast of Columbia Falls, that helps animals get around Columbia Falls up and down the Flathead River. Then my coworker Ryan helped conserve 50 acres near Swan Lake, and during this next year we should see the 20-acre piece there to the east of the Swan River also conserved. Can you believe the foxes were on that property? I mean, that's the perfect picture, right? But they had a den on his Swan Lake property. Then recently, just saw in the press probably, we completed the 36.5 acres along the quarter mile of Stillwater River, 30 acres along close to a quarter mile of the Whitefish River. And in the next year, there's 120 acres just to the north of an existing easement that will probably most likely get done next year. And then we've been increasing our work in the Mission Valley, like we mentioned, because the Mission Valley has some of the highest densities and concentrations of birds of prey wintering there in the nation. And of course, it's got lots of other bird habitat that's amazing, but some of the areas we've been working have these high densities of birds of prey in the winter. So we've got 3 projects basically that should close early in 2025 there. This one here is a 40-acre project that connects land east of Picking Horse, and then we've got 387 acres and 290 acres kind of west of Pablo and Ronan. We also completed 122-acre easement along Mission Creek this year, and we've got a new conservation project that we applied for funding for that's 671 acres south of St. Ignatius. It actually has nesting great gray owls on it, along with lots of other bird use. And then we're working on a project that's 900 acres, we also applied for funding for, west of Polson, that has long-billed curlew nesting on it and other native grassland birds, because it's got about 140 acres of grass on that's never been cultivated that is in really good condition, and lots of forbs and wildflowers in the spring used by grasshopper sparrows and hornlarks along with the curlew. That's pretty cool. So I guess this year we completed about 7 projects. Next year we should complete at least 6. So it's pretty exciting. Time's up, and lots of projects in the pipeline for the Land Trust. So does anyone have any questions? Go ahead.
Back to your bird presentation with the 7th graders. What's the one thing that just kind of blows their mind, that is just so eye-opening, that you get the most questions on?
Well, the very first presentation I do had the most interactive part of the presentation tonight. And when they start going through and kind of flapping their arms and figuring out how fast a hummingbird's wings can go, and then thinking about how hard it is for birds to travel and how much it would take for hamburgers compared to birds for them to eat if they were a bird. I think that whole thing really gets them excited. They, you could just see their behaviors. They get excited. They start asking lots of questions. It's pretty fun. They like that the best, I'd say. But it is interesting, I guess throughout the whole school year, watching them listen to different things, and different kids pick up on different things. But when you play the Jeopardy game at the end of the year, they've all pretty much been listening. It's pretty interesting to watch that. And I guess they just kind of, in a general sort of way, maybe had never noticed birds before, or thought about birds before, or thought about where we live as being special for birds or special at all. So I'll tell them things like, we're going to go see the spring migration, but not all kids in 7th grade in the U.S. can go do this. This is really special. We live in this flyaway where there's a chance to do this, and it's really amazing that there's hundreds of thousands of birds that come through every year, and they're just kind of like, really? I mean, it's just kind of cool. I like that part of it. Yeah.
I think you're doing amazing. I could sit and do this. Well, I had a shoulder surgery, so I was down for quite a while. And you'd find you do migration. It's just cool that we have, these videos that we can see.
Yeah, I mean, it is pretty amazing. The videos kind of really tell the story better than a person can. And so to see the quality of the videos out there, the short clips to share with kids, and to be able to put it together in a way that keeps their attention is a huge improvement over years past, for sure.
Mm-hmm.
Yeah. In the back.
If my math was right, 4,500 times in a swan.
Wow. 4,500 times in a swan, that's pretty funny. All right.
How much do they weigh?
A swan can weigh up to, I think it's over 30 pounds, and I think maybe the heaviest one was like 35-ish pounds.
Okay, then I gotta redo my math.
But some people will say to me, well, like adults will be like, what's the heaviest bird? Pelican. I'm like, oh, pelican's pretty heavy too. I mean, there's other birds that are up there with the swan, but the trumpeter swan.
Just hearing one
yeah.
when they lift off and then it's like, wow,
Yeah. Yeah, and the other things that we talk about with the kids are, so like, swans are kind of in between diving bird, or diving duck and a dabbling duck, right? Because they tip their tails up to feed, but they have to run across the water to get enough speed to fly because they're so heavy. So there's all kinds of things, and the kids, you can see the wheels turning in their head, thinking through all these different things, and that's kind of cool too. And then you can talk about how geese have a little longer necks than ducks, and then swans are even longer because then they can reach different depths and have different food sources available to them in a competitive world. So, I mean, I think all that's just really important versus, I mean, it is fun to learn the names of birds, but I think it's more important to learn about the birds because you can really enjoy watching them without knowing their names, and it's pretty hard for a kid to be able to see the bird well enough to pick up on all the characteristics, but also to learn all those names. But they are paying attention to all those characteristics and feeling kind of good about themselves, I think, by the end of the school year. And so we have binoculars for each kid on all the field trips, borrowed from Fish, Wildlife, and Parks, and we have you guys, some of you guys helping with spotting scopes so that the kids can get a really good view at stops on each trip. And we do need volunteers every year to help with those spotting scopes because we have to divide the kids up into smaller groups to keep their attention and rotate them through stations. And so having volunteers is really key to the success of the field trips. And there's lots of field trips, so spreading out the field trips among different people versus having the same folks have to help so much is really nice too. And this year I'll have some field trips in the Mission Valley, which is possible. I'll get some help from down there, but if anyone wants to travel down to help, I could use volunteers down there. So it'll be March, mid-March for church SLU, basically before spring break for the kids. And then I think this year there'll be a possibility to extend a little bit into April to fit in all the field trips. And in the fall, it's usually at the end of September, before duck hunting season opens, to watch the cranes and get the field trips in. For the Mission Valley, there are staging areas used in the Mission Valley. I haven't figured them out quite good enough for a field trip, so I don't know if I'm going to be doing those down there, but I will be doing the spring migration to look at the spring migration at Nine Pipe for sure, and probably birds of prey tours, similar to the one we do with adults for the kids. Because I know even the teachers, some of the teachers are like into science, but not necessarily birds. And the teachers I've talked to in the Mission Valley are like, yeah, I guess I do see hawks all the time. I didn't really think about that being special. I mean, people don't know how special they have it in a place. So you point things out. And I think it's good for people to know and appreciate their surroundings. All right, thanks so much, everyone.